Welcome to The Explainer. Today, we're diving into a practical blueprint for building a robust, multi-service system with Kafka. So, if you've ever found yourself lost in a tangled mess of microservices, well, this is for you. Okay, so here's our game plan. We're going to start with the problem we're trying to solve. Let's call it the spaghetti problem. Then we'll introduce the solution, a kind of central bulletin board. We'll lay down some essential rules of the road, then walk through the actual system blueprint. And of course, we'll see how to build a safety net to make it all reliable. And finally, we'll map out your first steps to get going. So let's kick things off with a real architectural headache, one that I'm sure many of you have run into as your systems start to grow. Yeah, this is what we mean by spaghetti architecture. It's this incredibly complex and brittle web where every service is calling every other service directly. Billing needs to know exactly how to talk to identity, which in turn needs to know all about the company service. They're all just stuck together, totally coupled. And this right here is the biggest danger. A single failure can cascade and ripple through the entire system. You know, if the identity service flips out for just a second, any other service trying to call it is going to fail too. It's a domino effect that can bring the whole operation to a screeching halt. Super fragile and a total nightmare to maintain.
So, how do we untangle this mess? Well, this isn't about some small tweak or a minor fix. We're talking about a fundamental change, a real paradigm shift in how our services communicate with each other. The core idea here is actually pretty simple, but it's incredibly powerful. Instead of services asking each other for information, they just announce facts about things that have already happened. The billing service doesn't call the identity service directly. Nope. It just announces to the world, hey, just so you know, a payment failed for this account. And this slide just nails the difference, right? In the old way, service A and B are locked at the hip. But with Kafka acting as our central bulletin board, service A just posts its message. It has no idea who's listening, and honestly, it doesn't care. If a service that's supposed to be listening is down, no big deal. The message just waits safely in Kafka until that service is back online. This makes the whole system so much more resilient and flexible. But for this whole thing to work at scale and not just turn into total chaos, we can't have a free-for-all. We need to set up some ground rules, some non-negotiable principles that every single service in our system has to live by. These 5 rules, they're the absolute bedrock of this entire system. Each service is the king of its own castle, its own data. No service ever messes with another service's database directly. And, super importantly, we have these patterns to make sure messages are sent exactly once and processed exactly once, even when things inevitably go wrong. All right, let's get to the really fun part, the actual blueprint. This is where we see how all these ideas and rules come together to build a practical, real-world architecture. First things first, we gotta get organized. In Kafka, we do this with what are called topics. You can think of them as dedicated channels or mailboxes. All events about user accounts, they go into identity events. All the payment stuff, straight to billing events. You get the idea. It keeps everything neat and tidy and stops messages from getting all mixed up. Now this is so important because of the discipline it creates. Every single message, doesn't matter if it's from billing or courses or identity, it gets wrapped in this exact same structure, this standard envelope. This gives us amazing consistency across the board, which makes it so much easier to process, monitor, and debug everything that's happening in our system. So we have our channels and we have our standard message format. Now let's see this thing in action. Let's look at what specific services are actually saying and what they're listening to. So the company service is basically the ultimate source of truth for any organizations on the platform. It's the one responsible for announcing all the key facts, like when a new company signs up, when their details change, or when a new login domain gets added for them. Meanwhile, you have the identity service. It owns everything related to users. So it's the one announcing when a new user account gets created, when a user is linked up with a company, or when new roles and permissions are set up. And here is where the real magic happens. It's not just about what a service says, it's also about what it listens to. So when the company service announces a new domain, identity hears it and updates its own data. And even more powerful, if the billing service announces a payment failed event, the identity service can hear that and react by, say, restricting that user's account. That is loose coupling in action. Okay, this all sounds great on a whiteboard, right? But we all know that in the real world, things break, services crash. So what happens if a service dies right in the middle of sending or receiving an event? How do we stop data from getting lost or messed up? The outbox pattern is our safety net for sending messages.
The genius of this is making the write the event step part of the exact same atomic database transaction as the business change itself. So you save the new user and the user-created event together. If one of those steps fails, the whole thing rolls back. This guarantees you never lose an event before it has a chance to be sent. And then, on the receiving end, we need to make sure we don't accidentally process the same message twice. The inbox pattern solves this. Before it does any work, the service checks a local log of event IDs it's already handled. If it's a new event, great. It does its thing and then adds the ID to its log, all in one transaction. If it's seen it before, it just safely ignores it. No double process. Okay, this is a pretty comprehensive blueprint, I get it. But the good news is, you don't have to boil the ocean. You don't have to implement every single possible event from day one to get started. You can get some really powerful end-to-end connectivity in your system by just starting with this core set of events. These are the big ones, the critical announcements that link all your major services together. Creating a company, adding a user to it, setting their subscription limits, creating a course, and tracking their progress. This is your MVP, your starting point. And there you have it, our blueprint for building a robust, event-driven system with Kafka. The real key takeaway here is to start thinking about your services not in terms of what they need to ask for, but in terms of what facts they can announce to the world. So my question to you is, what's the first, most critical event your system needs to announce? That right there, that's your starting point.